Okay, so average intensity of load, the formula is total load, total load total load into impact factor. Already we have calculated what is impact factor divided by, this is getting slow, impact factor. Okay, impact factor divided by dispersion length, dispersion length, dispersion length into dispersion width. Okay, so total load of IRC class AA tracked vehicle is 700 kilonewton. Okay, into impact factor, we have calculated impact factor that is 19%. We need to increase it by 19.7%. Okay, 19.74%. We need to increase the load. So that will come as 1.197 divided by dispersion length. We have calculated that is 4.76 meter, and dispersion width also we have calculated total dispersion width that is 7.455. 7.455. Okay. So by using this, you will be getting the average intensity of load. The average intensity of load is 23.61 kilonewton per meter square. Now you can find maximum bending moment due to live load. Okay, you got the intensity of the load. Now you can find the maximum bending moment. So this is the beam, or you can call it as slab culvert, the slab culvert that you have. And in order to find the maximum bending moment due to live load, we need to place the UDL at the center. Okay, and the total distance of the UDL is nothing but the dispersion length, which is equal to 4.760, and the intensity of the load that we have, this is 23.61, and the maximum bending moment will be at the center. You can easily find, this arrangement, the length of the beam is 6.4 meter. You can easily find what will be the maximum bending moment. Okay. The maximum bending moment, I leave it to you how to find. You first need to find the reactions, and then you have to find the bending moment at this particular point. So you know how to find the bending moment stuff. Okay. So I will not go into that. Bending moment equal to 113 kilonewton meter. So this is bending moment due to live load. And already in the previous class, we have calculated the dead load bending moment. Now total design bending moment, total design bending moment, total design bending moment equal to live load bending moment, that is 113, plus dead load bending moment, that is 72, equal to 185 kilonewton meter. But we are not interested in total design bending moment. We are interested in total design ultimate moment. And that is given by IRC class, IRC 112. What will be the total design ultimate moment? So that total design ultimate moment will be considered for the design of the slab. Okay. So as per IRC 112 2020, total design, total design ultimate moment, ultimate moment equal to 1.35 MD That is dead load bending moment plus 1.5 ml. ml is live load bending moment and md is dead load bending moment. Okay. So 1.35 into dead load bending moment, that is 72, plus 1.5 into live load bending moment, that is 113, which is equal to 267 kilonewton meter. 267 kilonewton meter. So this is how you will find the bending moment in the slab culvert. So our next topic is to find the shear force due to IRC class double track vehicle. We have calculated bending moment, and the next thing is to find the shear force. Okay, find shear force. Shear force, shear force due to IRC class double A. Okay, in case of bending moment, you have put the load at the center. Why you have put the load at the center? Because you want maximum bending moment. But to get maximum shear, the UDL should be near to the support. UDL should be near to the support. Okay. So this is how you need to place the UDL. This is how you need to place the UDL. And the distance of the UDL is nothing but dispersion length. This is 4.760. Now you see when you change the position of the UDL, X will also change. Already I've seen in B effective formula. What is X? In B effective formula, what is X? X is nothing but the distance of the center of gravity of the load from the nearest support. Okay. So this is the center of gravity of the load and this is the nearest support. So this will be your X. In the previous case, this was your X. And in this case, this is your X. So here X is getting changed. Since X is getting changed, B effective will also change and intensity of load will also change. Here intensity of load will not remain same because X is getting changed. In the bending moment, this was the X in bending moment case, but here in shear force case, this is your X. Okay. So what is X? X is nothing but 4.760 divided by 2. Okay. So again, we need to invoke that formula. We need to invoke that formula B effective equal to K into X. K will remain same. Only X will change. 1 minus X by L plus BW. BW will also remain same. Only X will change. Okay. So what is X? X equal to 2.380. Okay. So K value is already we have calculated. K is 2.84. 2.84 into X. X is 2.380. 1 minus X 2.380 divided by L is 6.4 plus BW is 1.01. So in this case, the B effective, you are getting it as B effective is 7.303 meter. So again, you need to find the total dispersion by putting the B effective X formula. See, I will go to that, where we have calculated a total dispersion. So this is where we have calculated the total dispersion. Only B effective will change. Else everything will remain same. B effective value will change for the shear force because for the shear force, X is different. Since X is different, B effective will be different. All the things will remain same. Okay. The total dispersion along the width again we need to find because B effective is changed. Okay. Total dispersion. total dispersion, total dispersion, B effective by 2 plus, anyone can tell me what it will come? Plus 0.85 by 2 plus 1.2 plus 0.85 plus margin 1.2 plus footpath 1 meter. So this is the total dispersion that you will be getting. The total dispersion for shear force will be 7.303. So again, you need to find the intensity of the load. Total dispersion length will remain same, but dispersion width, the total dispersion width for the shear force will be different. Okay. So average intensity of the load, average intensity, average intensity of load equal to total load, total load into impact factor divided by dispersion length, total dispersion length, total dispersion length into total dispersion width, dispersion width. Okay. So total load of the IRC class AA track vehicle is 700 kilonewton. Into impact factor, we have seen that is 19.7%. We need to increase 19.7%. Okay. 1.997 197 divided by dispersion length is 4.76 and dispersion width is 7.303. So the intensity of the loading for the shear force is 24.1 kilonewton per meter square. Okay. So you need to find this shear force due to live load. This is your bridge. The total span is 6.4 meter. And in this way, you're putting the UDL to get the maximum shear. Maximum shear will be at this support. Okay. The intensity of load that you have gotten is 24.1. The length of the UDL is 4.76. So the reaction at the left support is nothing but the maximum shear. Okay. So you need to find what is the reaction at the left support. So I'll directly give you the value. VA is nothing but the maximum shear, which is equal to 72 kilonewton. Okay, so this is the maximum shear that you're getting because of the live load. You also have to find dead load shear force. I think we have not calculated. Dead load shear force, the loading is, the loading is uniformly distributed over the span, dead load, and this is 14. We have calculated what is the dead load, okay, 14, and this is 6.4. So here you will get the reaction. The reaction itself is the shear force. So the dead load shear force is 45. Okay. So total design shear force is total design shear force equal to 72 is the live load shear force plus 45 is the dead load shear force, and you're getting it as 117 kilonewton. But we are interested as per IRC 112, we are interested in the total design ultimate shear force. Total design ultimate shear force. We are interested in that. Okay. Total design total design ultimate shear force. Okay, which will be equal to 1.35 VD dead load shear force plus 1.5 VL live load shear force. So 1.35 into 45, okay, plus 1.5 into 72. So this you're getting it as 169 kilonewton. Okay, up to this is clear? Any question, class? The next part is the design part, design of bridge. We have done the analysis. We have calculated the bending moment, live load bending moment, and dead load bending moment. Dead load bending moment is easy, but live load bending moment you need to do some complex thing, and we have done that. And after that, we need to find live load shear force. See, the load for live load shear force is different. I told you the reason. You can see the recording. I will share the recording. Once again, you revise the lecture. Okay. And after load shear force, we have calculated dead load shear force. And after that, we have calculated as per IRC, we need total design ultimate shear force. Total design ultimate shear force is 1.35 VD, that is dead load shear force, plus 1.5 VL, that is live load shear force, and you are getting it as 169 kilonewton. Okay. Any class question? Sorry. Any question, class?
No,
You
sir.
have any question? Okay, so we will not continue. We will continue in the next class. Design part is remaining, design part and some check is remaining, and then this problem will be over. The design of slab culvert will be over. I will also show you the detailing, how the detailing has to be drawn. Okay, we need to find the reinforcement, whatever bending moment we have gotten. For that bending moment, we need to find the reinforcement and we need to provide the reinforcement in the bridge. Okay. If you have any question, you can ask, or we will continue in the next class. The next class I will take on Monday. I will inform you because we miss many classes. I think I will take the next class on Monday or Tuesday. I will inform you in the group.
Okay, sir.
Okay.